The pillars of creation by now have been destroyed some 1,000 years ago. After all, the image captured by the Hubble Space Telescope occupied an area of space some 7,000 light years away from us. This means the image we see, courtesy of NASA, appears as it was some 7,000 years ago, since that's how long the light information took to travel from its location in the Eagle Nebula to the Hubble telescope. What we do see in this famous image are two 4 light-year tall columns, billowing pillars which offer a glimpse to embryonic stars. It got its name because the columns are factories for creating stars. In fact, the pillars themselves are the product of a massive nearby O-type star that sculpted the gas with its powerful winds. But the image is deceptive. When you look at it, you're not really seeing it as it would appear to you if you were actually floating in front of it and able to take in the scene how it fills the frame. The image shows large pillars stretching upwards, at least stretching upwards to the top of the frame as it is normally displayed to the public. After all, there is no up or down when in space. There are 2 main pillars with a third, smaller one shunting out like a ghostly specter. They have this gradient hue, the mixture of brown, orange, green, and red. The backdrop is a bed of starlight immersed in a haze of green, blue, purple, and orange. It looks like a gaseous injection taking the form of fingers pulling at a sheet of darkness pinpointed with specks of light and dappled darkness. Actually, the blue colors you see in this image represent oxygen, and the red is sulfur, and the green you see represents both nitrogen and hydrogen. If you look close to the edges of the pillars, you can see what appears to be beams of light streaming from behind, and the pillars are actually bathed in scorching ultraviolet light from a cluster of young stars located just outside of the frame. Even though it looks small and possibly like something you might find in a murky lake, the 4 to 5 light-year-long pillars are relatively just a small sample of the entire Eagle Nebula, which spans 70 by 55 light-years. So you're seeing an enormous amount of information when you look at this picture, as well as seeing it in a way that our human eyes could never really see it. After all, our eyes can't do long exposures. This is why we can't see in the dark. Our eyes are basically meat cameras that refresh themselves every second or so. But there's more to it than that. Not only does the Hubble telescope have the ability to gather light information for long periods of time, but it also can see in wavelengths our eyes can't even detect. Furthermore, it acts almost like a digital camera, relying on a team of scientists back on Earth which assign colors to certain types of information. Hubble doesn't use film. Instead, it uses something called a CCD, or charge-coupled device, to record incoming photons of light. And it doesn't measure the color of incoming light directly. Instead, the telescope uses various filters that can be applied to let in only a specific wavelength range or color of light. Hubble is detecting light throughout the visible spectrum, plus ultraviolet and infrared light, which are invisible to the human eye. It will take photos of an object multiple times using multiple filters. Then, back home, scientists combine the images and assign colors to the data. That is to say, blue light to the data from the blue filter, red light from the red filter, etc. This is all combined to make one comprehensive color image. The color in the image is really used as a tool, whether it's to enhance an object's detail or to visualize what ordinarily could never be seen by the human eye. Sometimes the light and hues given off by an object is so faint that the telescope will let the light build up in its CCD over time. Scientists will also assign colors to the wavelengths we can't see by using slightly different shades of colors already used. It's equal parts art and science, and it allows us to see space in a way we normally wouldn't be able to see it. But it wasn't always this way. In fact, the Hubble Space Telescope had a rocky start. The pillars of creation actually marked a comeback of sorts for Hubble. And that's what makes the image of the pillars of creation so important. It's not just about the enormity of beauty captured in the image, but the history leading up to it. When the Hubble Space Telescope launched, it had a flaw in its optical system. With all the hype being what Hubble could produce, the images it sent back were out of focus and unremarkable. It was underperforming what it was designed to do. The project had cost $1.5 billion to launch and would cost billions more to maintain. So the scientists behind the Hubble team were under a lot of scrutiny and pressure to fix the issue. They were being ripped apart in the news, and the taxpayers and politicians were not happy. It turns out shortly after the telescope's launch in 1990, operators discovered that the observatory's primary mirror had an aberration that affected the clarity of the images. It was figured out that there was a miscalibration in the equipment during the mirror's manufacture. The result was a mirror with an aberration 1/50th the thickness of a human hair in the grinding of the mirror. It took a team of astronauts to fly up to the Hubble telescope to fix it. Replacing the mirror wasn't practical, so they opted to build replacement instruments that fixed the flaw much the same way a pair of glasses corrects the vision of nearsighted people. So yes, in a way we had to send Hubble a pair of space glasses. Pillars of Creation was published almost 2 years after astronauts successfully fixed the issue, and it ushered in a new chapter to Hubble's ongoing odyssey of discovery. It was the first image that really made the public realize how important Hubble was and the potential it had to offer. No one had made an image quite like Pillars before. Sure, there were pictures of the cosmos taken before, but nothing quite like the Pillars of Creation. The shadows of the pillars made the image look three-dimensional. There was depth and clarity never seen before. It helped scientists gain a deeper understanding to star creation, and we're still gaining insight from this region of space. The pillars themselves are products of a massive nearby O-type star that sculpted the gas with its powerful winds. O-type stars are the universe's largest, hottest stars and live relatively short lives. They also wreak havoc on their environments. They emit intense radiation which heats up surrounding gas to form expanding bubbles. According to recent simulations and tests, the pillars were naturally formed along the outer rim of such bubbles as they expand and rip at the edges. The future of the bubbles can follow one of three paths. It may expand forever, expand, contract a little, and then become almost stationary, or expand and then contract all the way back to the center of the cloud. It's the second case that leads to prolific star formation, but even then under certain circumstances. Those bright rims which can be seen around the pillars also naturally form along the outer edge of the bubble as it breaks up. The bubbles around O-type stars often destroy star-forming clouds. However, in other cases, they compress surrounding gas to initiate the birth of stars sooner than they would have arisen, causing them to be smaller. Destruction and creation appear to go hand in hand. But at a cosmic scale, just like in our lives, things move constantly. The shape and form of the cosmos is always in flux. So when you look at the image of the Pillars of Creation, you see it as it appeared 7,000 years ago. That's how long it took the light and the information to arrive to us from 7,000 light years away. Earlier, it was stated that the pillars have been destroyed. Well, as it turns out, there was a supernova explosion some 6,000 years ago, and with our telescopes, we can see the supernova advancing, unstoppable, destroying everything it touches and approaching the Pillars of Creation. From Earth and how we see things, the shock wave has not reached the pillars yet. However, in 1,000 years, we will see them blown away. In actuality, the shock wave from that supernova has already destroyed the pillars, but we won't be able to see it for ourselves in a millennium. Since light has to travel a vast distance, the information will arrive to us after the event has already occurred. The further away something happens, the longer it takes to reach our eyes. When you look up to the sky, you are actually looking at the past. Seconds, minutes, years, centuries, millennia, and even more. Everything we know and have accomplished today wouldn't be able to be seen by anyone from the vantage point of those pillars. If there's some telescope around those space coordinates using some advanced telescope beyond our own present capabilities that could zoom in on Earth, they would not know of our existence unless they waited around 7,000 years. For them, in that part of the galaxy, we don't exist. The Hubble Space Telescope has made more than 1.4 million observations over the course of its lifetime. There have been over 18,000 peer-reviewed science papers published on its discoveries, and every current astronomy textbook includes contributions from it. It has tracked interstellar objects, watched a comet collide with Jupiter, and discovered moons around Pluto. It has peered back into our universe's distant past to locations more than 13.4 billion light-years away. It may have had a blurry beginning, but its images are tack-sharp today, even after being in operation for over 30 years. The Hubble Space Telescope has changed our understanding of the universe, deepened our knowledge of the cosmos, and sparked our imagination for what might be out there. And it really all started with that one comeback image of the pillars of creation.